in kinetic, so we're going to use that kinetic energy formula of 7.26 kilogram bowling ball that is rolling at a speed of 2 meters per second. So we're going to use the kinetic energy formula. That is, kinetic energy is equal to 1/2 mass times velocity squared. So let's list what we know. The kinetic energy, we don't know that. We're going to have to figure that out. So I'm putting a question mark. The mass, they tell us the bowling ball is 7.26 kilograms. And then the velocity is 2 meters per second. Now we just plug in what we know and solve for what we do not know. Kinetic energy is equal to 1/2 times the mass, which is 7.26, times the velocity, which is 2, and that has to be squared. 2 squared, or 2 times 2 is what? 4, right? So you would say kinetic energy is equal to 1/2 times 7.26 times 4. Kinetic energy is equal to, and then you have to multiply all those numbers together. And what's our final unit there for kinetic energy? Huh? Joules, capital J, right? Good. Y'all understand how to do that? Okay, number 3. An apple has 6 joules of energy. The apple sits on a counter that is 3 meters high. What is the mass of our apple? So since this gives us a height, that also gives us a clue that we use that gravitational potential energy formula. So GPE, gravitational potential energy, is equal to, remember, ham. The height times the acceleration due to gravity times the mass. So let's write out what we know. Gravitational potential energy is equal to 6. Is this from Mr. Aaron? There you go. Thank you. Okay, so our gravitational potential energy is 6 joules. The height, they tell us, is 3 meters. The acceleration due to gravity, remember, that's always the same number. It never changes. Meters per second squared. And then our mass, they don't know. They're like telling me what that is. So we're going to have to solve for the mass. So now we just plug in what we know and solve for what we do not know. So gravitational potential energy is 6, is equal to the height, which is 3, times the acceleration due to gravity, which is 9.8, times the mass, which is the m. Because we don't know what that is. We're going to solve for that. If you were to take 3 and multiply it by 9.8, what would you get? 29.8? 29.7?
27.8.
27.8.
Oh, okay. I didn't get that. I got a different number. Let me see. 3 times. Okay, so I get 29.4 m. Now to get m by itself, I'm going to divide both sides by 29.4. And then 29.4 cancels out over here. So m, or the mass, is equal to 6 divided by 29.4. And what is our unit going to be for mass? Kilograms. Good. Whoops, let me scooch that over so you can see it better. Sorry about that. So you're going to have to figure out the number. So do the math and figure out the number on that, okay? Number 4, 2 objects are being lifted by a machine. One object has a mass of 2 kilograms and is lifted at a speed of 2 meters per second. The other, so it has a second object, the other object has a mass of 4 kilograms and is lifted at a rate of 3 meters per second. Letter A says which object has more kinetic energy while it's being lifted. So we're going to have to figure out the kinetic energy for both objects, object 1 and object 2. So first, let's write out our kinetic energy formula. Kinetic energy is equal to 1/2 mass times velocity squared. Okay, now let's write out what we know for object 1. The kinetic energy, we don't know. They're asking you to find out what it is. So I'm going to put a question mark. Let me scooch this over just a little bit. The mass of the first object is 2 kilograms. And the velocity of the first object is 2 meters per second. Now then, if you do object number 2, the kinetic energy, again, we don't know what that is. We're going to have to figure it out. The mass of object 2 is 4 kilograms. And the velocity of object 2 is 3 meters per second. So now we just do the calculation. Let's start with object 1. So kinetic energy is equal to 1/2 times the mass, which is 2, times the velocity, which is 2, and it has to be squared. So kinetic energy is equal to 1/2 times 2 times, and what's 2 times 2? 4. So what is 4 times 2? 8. And then 8, what is half of 8? 4. So the kinetic energy here is equal to 4. And what's our unit for energy again? A capital J, right? So for object 1, our kinetic energy is 4 joules. Now then, for object 2, let's do it real quick. The kinetic energy is equal to 1/2 times the mass, which is 4 kilograms, times the velocity squared, so 3 squared. So the kinetic energy is equal to 1/2 times 4. What's 3 times 3? 9. So what's 4 times 9? 4 times 9 is what? Liter. 4 times 9 is what? 36. Hang on, let me get my computer screen went down. Let me fix it real quick. 36. What's half of 36? Right. So the kinetic. Would you agree that kinetic energy is 18? And what's the unit for that? Joules. So object 2's kinetic energy is going to be 18 joules. So back to the original question, it says which object has more kinetic energy, object 1 or object 2?
Object 2.
Right. Object 2 has to have more, right? Object 2 has more kinetic energy. And then letter B says, what does this tell you about the variables that impact kinetic energy? And so the best answer I had for that was what is listed in your unit packet on that reading page for kinetic energy. It says, if you double the mass of an object, you double its kinetic energy. If you double the velocity, see those are the variables we're using to find kinetic energy, the mass and the velocity. So if you double the mass, you double the kinetic energy. If you double the velocity, look what happens to the kinetic energy. It increases about 4 times. It quadruples. So that's what you can write there. If you double the mass, you double the kinetic energy. If you double the velocity, you quadruple the kinetic energy. Okay? So that's what you need to write there for letter B. Right here. You need to write that in there. If you double the mass, you double the kinetic energy. If you double the velocity, you quadruple the kinetic energy. Okay? So that's what you need to write there for letter B. Right here. You need to write that in there. If you double the mass, you double the kinetic energy. If you double the velocity, you quadruple the kinetic energy. Okay? So that's what you need to write there for letter B. If you double the mass, you double the kinetic energy. If you double the velocity, you quadruple the kinetic energy. If you double Scooch it over a little bit. I don't write the word quadruple very often. It looks kind of like a funny word, doesn't it? Underneath that, I'm going to put 4x because that's going to remind me it's 4 times more. Okay? Now then, letter C asks us to find the potential energy of those two objects if we have a height of 10 meters. Okay, if it's lifted a distance, so that becomes your height. So now we use that gravitational potential energy formula. Remember, it was GPE is equal to ham. Okay, so now we have to find the GPE for object 1. So for object number 1, the GPE is, we don't know. We're going to solve for that. The height they gave us over here, it's 10 meters. The acceleration due to gravity, remember that's always the same, 9.8 meters per second squared. And then the mass, we have to go back. Remember up here for object 1, they gave us the mass, which was 2 kilograms. So I'm going to plug that in for that here. The mass is 2 kilograms. That's object 1. Now I'm going to just fill in the stuff for object 2. For object 2, the GPE, we don't know. We're going to solve for that. The height is the same, 10 meters. The acceleration due to gravity, remember that's always the same, 9.8 meters per second squared. And then the mass, we have to go back up here to where we calculated it up here and they gave us that value. The mass was 4 kilograms for object number 2. So I'm going to put 4 kilograms in down here for the mass. 4 kilograms. Okay, so now we just calculate GPE for both objects. So GPE is equal to the height, which is 10, times the acceleration due to gravity, which is 9.8, times the mass, which is 2. So you just multiply all those together, and that gives you the GPE for object 1. And what is our unit going to be for energy?
Joules.
It's capital J, right? For joules. So whatever number you come up with there, the unit is going to be in joules. So for object 2, to calculate the gravitational potential energy, we say the height, which is 10, times the acceleration due to gravity, which is 9.8, times the mass, which is 4. So the GPE for object 2 is equal to 10 times 9.8 times 4, and that's also going to be in joules for your final answer. Did anybody do the math for that? What did y'all get for object 1? 496. 196. For object 2, what did you get for that? 392. Oops, 20.